Hello students. In the previous classes we studied about Euclid's division lemma and fundamental theorem of arithmetic. We studied the theorems and their applications. Now our next task is to prove the irrationality of real numbers. So let's discuss about how to prove root 2, root 3, etc. as irrational numbers. So we are going to discuss about proof of irrationality of numbers. Now before proving irrationality of numbers, let us see once again what do you mean by irrational number. A number is called an irrational number if it cannot be written in the form of p by q, where p and q are integers and q is not equal to 0. So you know that root 2, root 3, root 15, pi and many examples of irrational numbers. So now here we will mainly focus to prove the irrationality of numbers like root 2, root 3, etc. So let us start learning how to prove them. Now before proving irrationality of numbers, let us first look into a theorem. The theorem states that let p be a prime number if p divides a square, then p divides a, where a is a positive integer. This is a very important theorem, very simple to understand. P be a prime number, and if p divides a square, then p divides a also. Let's take an example. If you take 3 and 9 square, you know 3 divides 9 square, means 3 divides 81. Then you know 3 divides 9 also, that is square root of that. If 3 divides 9 square, then 3 divides 9 also. Very simple to understand. The same way, let's take another one. 7 divides 441, or 7 divides 21 square. Therefore 7 divides 21 also. If p divides a square, then p divides a also. If p divides a square, then p divides a also. So this is very simple. To prove the irrationality of numbers, we have to make use of this theorem. So remember this theorem very properly. Now let's start proving the irrationality of number 2. Prove that root 2 is irrational. Now remember, these types of proving will be done by a different method which is known as contradiction method. We discussed about contradictory method and proving theorems earlier also. So how to prove root 2 is irrational? So what we do initially is that we will just assume something opposite to what is given in contradictory to the given statement. Here it is given root 2 is irrational. So let us assume that root 2 is rational. Just our assumption is opposite to the given statement, then we will finally come to the conclusion that our assumption is wrong, so root 2 is irrational. This is what we are going to do it. So first we assume that root 2 is rational. Now you know when a number is in the rational form, then it can be expressed in the form of p by q, where p and q are integers, q is not equal to 0, and also remember it is always in the standard form, so p and q are co-prime. What does it mean? Co-prime means the HCF of the numbers is 1. So P and Q are co-prime means there is no common factor between P and Q other than 1. So that is the most important part. So what we are going to do is that we will prove that this P by Q form will have something common. P and Q will have something common. That is what we are going to do it. So let's start. We will assume that root 2 be a rational number, then it can be expressed in the form of p by q. Now you see here root 2 can be expressed in the form of p by q. Why? Because we assume that root 2 is rational. And remember p and q are co-prime. That is the key to this solution. So let's again think of the next step. If root 2 is equal to p by q, if you square both sides, then root 2 square will become 2. This side will become p square by q square. If you cross multiply, you will get a 2q square equal to p square. That is p square is equal to 2q square. Means we are squaring both sides. So on squaring both sides, we get p square is equal to 2q square. This is the first equation. Now see here, 2q square is equal to p square. What does it mean? P square is a multiple of 2, or 2 divides p square. We are going to make it in that theorem format. 2 divides p square, or 2 is a factor of p square. If 2 is a factor of p square, 2 is a factor of p also. If 2 divides p square, 2 divide p also. This is the most important part. So let's write that step. 2 is a factor of p square, therefore 2 is a factor of p also. This is very important. This is equation number 2. This is the key. So we got that p has got a factor, that is 2. Now if p is a factor, p has a factor 2, then it means that p is a multiple of 2. So let p is equal to 2m, where m is some integers. Means p is a multiple of 2, 2 multiplied by something is p, so p is equal to 2m. We are taking in that way. See here, p is equal to 2m. Why? P is a multiple of 2 and m is any positive integer. So now you got p is equal to 2m. Now you look at equation 1, that is p square is equal to 2q square. So we are going to find p square again here. P square is equal to 2m whole square means 4m square. So you got p square is equal to 4m square. This is p square is equal to 2q square. Here p square is equal to 4m square. So left hand sides are equal, so we can equate the right hand side, that is 2q square equal to 4m square. 2q square equal to 4m square. So if 2q square is equal to 4m square, 2 can be cancelled from both sides, that is q square is equal to 2m square. What does it mean? Once again we are getting the format that 2 divides q square, so 2 divides q also. It means that q is a multiple of 2. So here once again we are writing the format in this way. 2 is a factor of q square, because q square is equal to 2m square, so 2 is a factor of q square, therefore 2 is a factor of q. This is equation 4. Now look at equation number 2 and look at equation number 4. Here we have written 2 is a factor of p, here we have written 2 is a factor of q. It means that p has got a multiple of 2, q also has got a multiple of 2. It means that p and q has got something common other than 1. That is 2 is common between in both p and q. So p is a multiple of 2, q is a multiple of 2. So they have some common factor like 2, which is against our supposition or against our condition that p and q are co-prime. We discussed p and q are co-prime, but we are finding that p and q has got a common factor 2. So our assumption is wrong. So root 2 cannot be rational. So therefore root 2 is irrational. This is the proof. See the complete steps. From 2 and 4, both p and q have common factor 2, which is a contradiction that p and q are co-prime. Since our assumption is wrong, root 2 cannot be rational, therefore root 2 is irrational. Students, understand it properly, go through once or twice or thrice till you understand it. This is very important, and almost all questions of this format will be done in the same way. Root 2, root 3, root 5, root 11, whichever you want to prove it, you can follow this format. Let us see another example. Prove that root 3 is irrational. Now you see there is no difference at all. Only we start writing in the same way, let root 3 be rational. Then it can be expressed in the form of p by q, where p and q are co-prime. Square both sides. Similarly like before, we got p square is equal to 3q square. Then you find that 3 is a factor of p square, therefore 3 is a factor of p, equation 2. Now since p is a multiple of 3, we can say p is equal to 3m, where m is some positive integer. Then square it, p square is equal to 9m square. Now 9m square, if you go for equation 1, p square is equal to 3q square, therefore 9m square is equal to 3q square. I'm not explaining it in detail because the same way you have done root 2, you can do it. 9m square is equal to 3q square, therefore q square is equal to 3m square. Therefore you will find q is a multiple of 3, or 3 is a factor of q square, therefore 3 is a factor of q. So here you will find that from equation 2 and equation 4, 3 is a common factor of p and q. It means our assumption of q and p are co-prime does not satisfy here, so our assumption is wrong, hence root 3 is irrational. This is actually exactly the same way we have proved root 2. So understand the first one, easily you can do this one. Same way you can do root 5, root 7, etc. So start practicing the questions of this type. Let's see a different question. Prove that 6 plus root 2 is irrational. Here most of the time in the question it will be given that root 2 is irrational. So you don't have to prove it. So you have to prove that 6 plus root 2 is irrational by assuming that root 2 is irrational. So let's see how can we do it. Here again we are going to do the same way. 6 plus root 2 we are going to assume that it is rational. And if 6 plus root 2 is rational, it can be expressed in the form of a by b. You know where a and b are integers, or p and q you can take. A and b are integers, comma b is not equal to 0. Now 6 plus root 2 is equal to a by b, you got it. So what we need to do is that don't go for squaring and so on, directly find the value of root 2. If you want to find root 2 here, what will be the a by b minus 6, you will get it. So you will get a root 2 is equal to a by b minus 6. Root 2 is equal to a minus 6b by b, because LCM is b, so a minus b minus 6 is a minus 6b by b. Now see here, the interesting thing is that a is an integer, 6 integer, b is an integer. Integer minus integer, you already know that integer minus integer is always an integer, and divide by another integer is a rational number. So a minus 6b by b, integer by integer, a rational number. So you are getting right hand side rational number, therefore root 2 must be rational. But we know that root 2 is irrational. So here we are getting root 2 is rational, but we originally know that root 2 is irrational. So our assumption is wrong, therefore 6 plus root 2 is rational. See the complete step. Why 6 root 2 is rational? Because a is an integer, 6b is an integer, integer minus integer is an integer, by b another integer, so it is rational. A, 6, b are integers, therefore a minus 6b by b is a rational number, therefore root 2 is rational. But we know the fact that root 2 is irrational, so our assumption is wrong, therefore 6 plus root 2 is irrational. Let's go to do one more example, that is prove that 1 by root 2 is irrational. Now the same way we will do it. We will start assuming that let 1 by root 2 be rational. And if 1 by root 2 is rational, you know that 1 by root 2, if it is rational, it can be expressed in the form of a by b. But here it is very important that once you write down 1 by root 2 is a by b, don't write root 2 is equal to b by a. That will be wrong. Now you may ask why. If you write root 2 is equal to b by a, but we know that b cannot be 0 but a can be 0. So b by a will become sometimes not defined if a is 0. So don't write down root 2 is equal to b by a. 1 by root 2 is equal to a by b means what you need to do is that after that rationalize the denominator by multiplying numerator and denominator by root 2. So let us see that step. So if you rationalize it, you will get 1 by root 2 into root 2 by root 2 is equal to a by b. That is root 2 by 2 is equal to a by b. Now it's simple. Root 2 is equal to 2a by b you are getting. What you need to initially do, rationalize and get the rational denominator. Then numerator is root 2, so there is no issue now. 2a by b. 2a and b are integers, therefore 2a by b is a rational number. 2a by b is a rational number. But we know root 2 is irrational. So our assumption is wrong. 1 by root 2 cannot be rational. It is an irrational number. Since 2a and b are integers, 2a by b is rational. But we know that root 2 is irrational. So root 2 cannot be equal to rational number. So our assumption is wrong. Hence 1 by root 2 is irrational. So students, practice these types of questions. Practice the textbook questions. We will be providing you more questions to practice. Thank you.